Hello, welcome to your first chapter on operating system concept. For this first chapter, we are going to look at an overview of an operating system. Now, before we start, here are some pointers that perhaps could be very beneficial for you when viewing the video for your lecture. So first of all, focus on understanding the material and not so much on memorizing or what is being shared in the video. And then of course, please take a 5-minute break after each 15 to 20 minutes viewing of the video and try to review key points of what you have viewed and cross-check with the slides that I will share on Moodle. And most importantly, try to participate and ask if you are unclear at any point that you are viewing the video with any ideas or perhaps theories that is being shared in the video. Okay, so without further ado, you can view the lecture. For today, we are going to look at the key function of an operating system, followed by the evolution and history of operating system, which as a result from those evolution comes the achievement and key design ideas areas for the development of modern operating system. So with that, the topic for today is the definition of OS, its objectives and function, followed by the next chapter, evolution of the operating system, and then the achievement and the development which leads to what we have today in our modern operating system. So on to part 1, the overview of an operating system. Now before we look at what an operating system is, we need to understand what makes a computer. And of course, most of you are actually viewing this on your computer. If let's say you are also viewing it on your phones, that is also considered a very small and portable computer nowadays, because basically nowadays phones have their own CPU, their own memory, and their own resources. So whatever you have today that has some processing is also considered a computer. So basically a computer consists of the hardware and its application. And of course, you are the user and you use those applications on the computer. For example, you have your web browser. You also have your perhaps Word or spreadsheet application. And usually you also have music application and other types of application, perhaps for gaming and also for viewing movies perhaps. So basically a computer consists of this component. You have the user, you have the application, okay, and then you have the operating system, and then you have the hardware. So basically in the computer, you have the operating system which manages the application and to interact with the hardware. Basically, each application has certain requirements from the user. So let's say perhaps you want to view a video on your computer. So you will perhaps click on an application to play the video. And then the application will send the request to the operating system. And then the operating system will make the necessary arrangement so that the application can use the hardware. So basically in a computer, again, we have the hardware, the application, and then in the middle, we have the operating system. Now we look at the core of today's discussion. So what is an operating system? So by definition, an OS is a program that controls the execution of every application program inside the computer. So an OS is considered an interface between application and the hardware. Remember, as a user, you send the request through the application, and then the application will actually send that request to the OS and the OS actually does the job of giving out suitable resources that can be used by the application. So these resources is perhaps how much memory that it can use, how much CPU time, or how much perhaps GPU memory that it can use. So these are the role of the operating system. So basically, OS is a program that controls the execution of every application that you have on your computer. It is an interface, meaning that it is the middleman between your application and also your hardware in the computer that you want to actually use. So hence, the objective of an OS, why is it made? Or perhaps when you actually compile your OS, so it will understand that its objective is first of all for convenience purpose. It wants to make the computer more convenient to use because you don't have to actually manually allocate memory for your program. You don't have to actually find the perhaps the driver that you want to use for your hardware, or you don't have to actually manage the memory that the program will use on your computer. And then secondly, by that, it is to actually provide efficiency. It allows computer system the resources to be used in a very efficient manner. Meaning if you have so much memory that you have on your computer, so your OS makes sure that those memory is being optimized to be used by each and every application that you have on your computer. And of course, third, it provides the ability to evolve. Remember nowadays, perhaps frequently you will have updates for your operating system, updates for your perhaps security patches, updates for your game. So the role of an operating system is to actually permit development and evolving of perhaps security patches and perhaps the codes that you have for your operating system application, meaning it provides the way for you to constantly uh, adapt to certain situation, certain new risks, certain condition, meaning that it helps you to actually evolve and optimize the use of your machine. So every time there is a new patches or there is a new development that needs to be done on your computer, the OS will assist you, the user, to easily uh, migrate from one version to another without so much hassle or so much requirement that you need to understand. Nowadays, you can just download the patches and the OS will done or will do the patch for you. So again, we look at the objective of an OS. First of all, for convenience, it is to make your life easier and make use of your computer much more easier. Efficiency, to make sure that whatever resources that you have on the computer can be optimized. And then third, it allows you to evolve and develop further its own codes and perhaps security patches. So for the first objective in terms of convenience, for example, you have application and hardware in your computer. So in this sense, the operating system here acts as the mediator, means that it helps you to actually allocate resources to the application that is requesting it. Like I said earlier, the resources, for example, is you have your memory, you have your CPU, you have your input and output devices. Of course, when you are using application, for example, you are using the browser. So let's say currently you are viewing YouTube, for example, or you are viewing Netflix. So let's say when you are clicking on those applications, so automatically the OS will decide, okay, right now you are actually wanting to use your headphones to actually hear whatever video or music that is playing. And then it also assign the necessary display driver to actually view those video that you want to view on YouTube. So this is what it means that the OS acts as a mediator. It actually masks the details of the complicated hardware mapping, okay, to make sure that you can use those resources flawlessly and your application runs immediately without you actually understand how does your machine needs to work. And then also, you need to remember that inside your computer, you have a set of utilities program to actually maintain and help you to manage or perhaps doing some cleaning, okay, spring cleaning on your computer. So basically, these utilities are being run and managed by the operating system. So whatever you want to do to manage the resources and perhaps do maintenance, again, the OS here to help you to actually do that very much easily with those utility function you have on your computer. So in terms of convenience, we have all this service that is provided by the operating system. For example, the OS will help you in terms of program development and program execution. It means that it helps you to actually write program without you to actually understand, perhaps not to be able to just talk in binary or machine language. Nowadays, you have C++, Java, Python, okay, that's actually more closely related or easily understood and closely to our human language. You don't need to actually talk in binary and talk in perhaps machine language for you to write a program. You can write simply in C++ or Java and Python that is closely to nowadays English language, and then it helps you to easily execute those programs. And then of course have access to I/O devices, meaning it easily assign your mouse, keyboard, headphones, okay, for example, to be used by the application. And then it provides you security in terms of control access to files, because not all files can be understood or can be actually understand the use by the users. So only expert users are being given privileges to run certain files on your computer. And then of course, protection to system access, followed by error detection, meaning if let's say something is wrong with your computer, your OS will run certain diagnostic program to actually give you solution or perhaps give you a selection of option to actually fix your computer. And then of course, provide accounting function. This in terms of, let's say, what you are doing on the computer is actually collected. Okay, and then let's say if certain things need to be understand or perhaps certain incident happen, so you can actually look at those log files to actually understand what actually happens, who actually access it, okay, what process is running, so that you can run proper diagnostic and help the OS to fix the error in the system. Secondly is the OS as the resource manager. So what are these resources? Okay, so the thing that you need to understand, for computer to run, they need these three main resources. So basically, you need a significant amount of memory to run multiple programs, because basically, executed programs are stored on your memory. By stating memory, it means that your RAM. Remember, when you want to actually buy your computer, you need to actually look at the spec, how much RAM is there. Okay, the purpose of having a RAM is to run current program that is running. Every running program needs to be stored on the memory. So the OS decides how many program can actually sit in the current memory. Okay, how many program will actually be transferred out. And then secondly is the use of I/O devices. Thirdly is the use of processor. Processor actually the one that is running those programs. So these are the three most important resources on your computer. You have the resources, secondly I/O devices, and third is the processor. So whenever I ask you what are the resources that is being managed by the OS, so you need to actually remember this: the memory, the I/O devices, and the processor. So as we previously established earlier, OS is actually also a program, but it is a very privileged program. The difference is that OS directs the processor and also schedule the timing of programs that is executing on the computer. Remember, in the Wall-E animation, you have this big process here. Okay, auto. So auto basically is the one that is responsible for managing the other processes on the ship. So all these robots, okay, represent every process that you have on the computer. Okay, so the purpose of this main program here, the OS, is to ensure that all these other programs execute well and properly managed and monitored so that the ship actually operates very well and the users is being treated whenever they want to do certain things on the ship. Okay, so it manages the resources there. You remember previously we have the memory, I/O, and also the CPU. So these are the purpose of the operating system. So the third objective of the operating system is to provide the ability to evolve. If you notice nowadays, you will constantly or perhaps on a daily basis will require to run updates on your computer. This is because hardware upgrades exist. There are certain patches that needs to be applied to perhaps, for example, games or perhaps your operating system in terms of the security patches. Because new services are being provided day to day, so the software are actually constantly updated. So the ones that is actually doing the updating each time a new patch arrives is the operating system. And usually these patches are to fix a flaw from existing or previous versions of the software or the hardware driver. So remember, for this part is the objective of the OS. Okay, and then of course the resources, and then of course what is the function of the operating system. So before we actually continue to the next section, okay, understand those points, and you may have a 5-minute break before we continue to the next part. Okay, part 2, we are going to look at the evolution and history of the operating system. Alright, so in terms of OS evolution, so basically the old computer we have a perhaps begin from serial processing, and then we have a batch system followed by the multi-program batch system and also the time sharing system. So of course, if these terms are a bit ambiguous or perhaps strange to you, don't worry, I will explain it on the next section. So first we look at serial processing. So in the earliest day or the old days of the computers, basically there are no operating system. So basically you have this big machine, and then this machine actually do mathematical processes, and usually the operating system is the human there, the computer technician. So these are the guys that actually operates the computer. So you don't have an automated program to actually do the management, you have actual people there. Okay, actually manages the computer. So whenever a task needs to be done, let's say they want to do certain calculation, so these guys will actually set up the machine to do those calculation. And it means serial processing that only one task can be done at a time. So imagine nowadays we can have multiple programs running in your computer. You can run your browsers in one side. You can also run this lecture. You also run perhaps any other program in the background. Okay, just imagine in the old days, you can have just one task. And then until that task is finished, because it takes a very long time, then you cannot have actually another program to run. So this is what it means by serial processing. Program is run in a series, okay, in certain orders. You cannot run multiple program at one time in the background. So this is serial processing. So of course, the problem in this implementation is of course in terms of scheduling. Because, okay, let's say you have perhaps 5 people that want to use the computer. So you need to actually fill up this form, and then you need to have a proper schedule. And then of course, there is a certain setup time, meaning that, okay, each and everyone that wants to use a computer, that need to have a considerable amount of time to actually set up those machines. So the problem there is on doing the scheduling, who can actually use the computer, and then the amount of setup time that we require for each of the people that comes in to use the computer. And then after a while, they came out with a simple batch system. So because early computers were very expensive, okay, so it is important to maximize processor utilization. Why? Because, okay, let's say previously we have the serial processing where guys are filling in forms and coming in to use the computer. And because this computer is very expensive, they cannot afford to actually waste time on setting up and perhaps do the scheduling and people coming in physically to use the computer. Something might be broken, for example, and perhaps the setup time takes much longer than is expected. So they came up with the simple batch system where we have now they develop a monitor system. So now when you want to use a computer, user no longer has direct access to the processor or the actual computer. Okay, so this time what happens is that job is submitted to a computer operator, so still actually a person actually, who batches them together and presses them in the input device. So just imagine, okay, you have a sheet of code that you want to actually execute on that computer. So you hand over the code to this computer operator, and this computer operator will actually input that in the computer. So basically, each user send those programs, and then this program then being run by the operator, and then the result is being shown after it is executed. So keep in mind, okay, just imagine, okay, nowadays you write your program. Of course, you will not be successful the very first time around when you write a program, right? So the problem is that when you actually send the job, you don't actually know whether that program will execute well or not. So you actually get the result perhaps a day later, and then you see, okay, there is an error in your program. Okay, and then you go back to your perhaps your place, you write again your code in the piece of paper, and then you send back to the operator. So user no longer has direct access, okay, but job can be done in batches. Of course, whether it runs correctly or not is another question, but this time you don't actually have to spend so much time on the setting up, because the one that is doing it is the computer operator, and then you just send the codes to the operator, and then the job is being executed and then give back the result after a day or two. So this simple batch system actually eliminates the need to actually schedule, so to manually schedule, and also eliminates the setup time. And then of course, people are no longer have to actually physically be there. They just hand over the job to the operator, and the operator does that for them. Of course, the operator is still a human being, but the idea here is that they have come up with the idea of an operating person. Okay, so before you have an operating system, the program that actually manages the resources. So during the batch system, you have people or the operator that actually does the operation or the operating of the computer on behalf of the user. So this is the second evolution, the simple batch system. So in a batch system, you have the monitor that controls the sequence of event, meaning when the code is given by the operator, the monitor, which actually is a software that always in the memory reads the code that is being sent and give control to whatever must be done by the computer. So let's say you want to do some calculation of numbers. So the monitor reads the job and gives control to that actual program. And then the job returns control to the monitor. The monitor will give result to the operator. So once the monitor gives the job, then you have the processor. So the processor will execute the instruction and then give the result to the monitor. The monitor will give it back to the operator. So in the batch system, okay, you imagine the big picture. You have the user, you have the monitor, you also have the processor, and you have previously the operator. So this is the very basic perhaps framework of what we have today in a modern operating system. So we have the user, we have the operator, we have the ones that's monitoring the execution, and we have the processor. So the basic building block are there, okay, to actually come out with the idea of what we have today in a modern operating system. So each instruction here in the batch system is a certain instruction, meaning what needs to be done with every process that is coming in that piece of code. So whatever being actually written by that code that the user is sending in comes in terms of the job JCL. Okay, so every job will come in terms of in this format. So because nowadays we have what we have C++, okay, we have Java, for example, we have Python. So in the old days we have the JCL. So in a simple batch system, we have the job control language. So simply put, this JCL actually tells the computer what compiler to use and what data to use with the code that you are actually sending. So the monitor actually gets this instruction of compiler to use and what data to use, and then it actually assigns the job to the CPU. The CPU does the calculation and give back the result to the monitor, and then the monitor will give that result to the operator. And then of course, after that, the operator will send the result to the user, okay, telling them, okay, your program runs smoothly perhaps, or perhaps doesn't run very well, and this is the result, or perhaps there is an error. So the user then need to actually perhaps be content with the result, or perhaps do a new code that needs to actually be fixed based on the result. Okay, so consider yourself lucky nowadays you don't have to actually put up with that kind of process again. Now, the idea that came from the batch system again after that there are certain ideas that came out with the implementation. So first of all, there is the idea of having memory protection for the monitor. This is because the monitor actually acts as the one that is monitoring the execution of other program. So the monitor need to have a very specialized and protected area in the memory so that its memory is always reserved and cannot be used by other program. And of course, the use of timer. It means that there must be a certain limit to actually prevent a job from monopolizing the system. Just imagine, okay, if a job runs for perhaps a very infinite amount of time, so other programs will not be able to execute. So the idea of having each program having a certain timer, okay, and then after that, after the timer is up, it needs to actually surrender the use of the CPU or resources and give way to other program to actually run. So the idea from the timer of the program came from the batch system. And then of course the idea of having privileged instruction. Okay, so this type of special instruction can only be executed by a special type of program or perhaps by only the OS or the monitor. And of course, lastly, the idea of having interrupts. So this idea gives more flexibility of the operating system in controlling the program. So remember you have the timer. So if the timer is up and then you activate the interrupt. So the OS can actually assign which program to actually stop, which program to actually run, which program to actually wait. So the idea behind the operating system that we have nowadays came from the batch system in the old days. And then from that came the idea of having different modes of operation. So we have after that the user mode and also the kernel mode. The user mode is where the user program executes, meaning certain memory areas are protected from user access and certain instruction may not be executed. And then you have the kernel mode, which during the batch system, we have the monitor that executes in the kernel mode. And then only special type of instruction may be executed. For example, the interruption of program or perhaps the scheduling of program. So only the monitor can actually execute those type of instruction. And the kernel mode actually have protected areas of memory that can be accessed by the monitor. So by having the user mode and the kernel mode, certain OS instructions are being protected. So meaning user cannot simply do whatever privileged instruction that they want, and the kernel there can actually be protected from being interrupted when it wants to actually diagnose certain error, for example, or they want to actually do serious management on the system. So this is also one of the important evolution or improvement that came from the batch system. So as a result of that different modes of operation, now processor time needs to alternate between the execution of user programs and also the execution of the monitor that is actually monitoring the computer. Because certain sacrifices needs to be made. Because you need to understand that the monitor is actually also a program. And then it also manages the other program under it. So of course, certain sacrifices needs to be made in terms of the use of memory. That's why, for example, when you have buy a RAM nowadays, let's say you buy a 4 gigs of RAM, okay, there is a certain portion of the RAM is actually being occupied by the operating system. So let's say you have 4 gigs of RAM, perhaps they have uh, 100 megabytes, for example, is being used by certain utilization program. And of course, processor time is also being consumed by the monitor, because in order to run the program, okay, remember we need to have memory, processor, and also I/O. So in this condition, okay, when a program needs to run in terms of memory program, it requires a certain amount of memory and a certain amount of processor time. Okay, so but despite having this requirement, this monitor operating and managing program improve the utilization of the computer. This is where we get the idea of having the use of processor time, CPU time inside the operating system that we have nowadays. So after the simple batch system come the next evolution. So we have now the multi-program batch system. So how the idea came to be? Okay, so earlier on, okay, for example, we have this situation. So we have the process of reading one record file. So we have, let's say, 15 microseconds in order to just read one record from a file. But when the time comes to actually execute 100 instructions from the file, it only takes 1 microsecond. And then when it wants to actually write the record to the file, again, it will spend 15 microseconds. So here, the total amount of being spent is 31 microseconds. Okay, can you see here? Okay, the percentage of utilization of CPU time is only 1 microsecond, while the other times, most time are spent just to read and write the record. So here the CPU is idle most of the time. So while waiting for the record to be read, it does nothing. And while waiting for the record to be write, it also does nothing. It only does the job, okay, after the read is being done, which is very fast, 1 microseconds. So by having a multi-program batch system, so they have the idea of why not, while waiting for the read and write, the CPU is doing other jobs. Okay, the requirement is that the processor is often idle, even with automatic job sequencing. So we have the I/O devices that are slow compared to the processor. The reading and writing process are very slow, but the execution of file is very fast. So this is how they came out with the idea of having the multi-program batch system. So in order to understand that, we look again at the concept of uniprogramming, meaning just one program running at one time. So in this situation, okay, we have one program that's run for a very short time, wait, for example, for the input and output devices, and then run again, and then wait again for the input and output devices. Okay, so the processor spends a certain amount of time executing, reach an I/O instruction, wait for the I/O to actually done, like say reading and writing, and then run again. Of course, the CPU is not being utilized optimally, because you need to remember the CPU can run very fast compared to the I/O devices. So this is uniprogramming, and the CPU time is wasted. And then came the idea of multiprogramming. So remember, let's say you have two programs, program A and program B now. Okay, so while program A run, program B can wait, and then while program A is waiting, program B can actually run. Okay, so when you have just two programs, you can see the CPU is doing something while waiting. Okay, so combined you can have program A and program B, and then of course you have the waiting again for I/O perhaps, and then program A and program B running. So compared to the previous implementation where you can just have one program running, so now you can have two programs running, okay, intermittently. So program A run, program B wait, program B wait, program A run. So imagine when you have multiple programs. Okay, this is what you have nowadays, where you can perhaps, for example, open multiple browsers, and at the same time you can also open your word processor, and at the same time you can also perhaps run a spreadsheet program in the background. Okay, so you need to remember that the CPU runs very fast. Of course, nowadays you have the requirement is you need to have a big enough memory to hold the OS and also hold the program that is in waiting. Okay, and because the program actually, the CPU actually processes very fast, so you didn't actually notice the switch between the program. So let's say you have 10 programs running at the same time, then the CPU will switch from one program to another, okay, while waiting for certain things to happen. And then it will interrupt it when the timer is up. Okay, this is where you have the concept of multi-programming. So in the example, you just have two programs. Now imagine if you have 10 programs. Okay, but of course, the requirement there is you need to have a fast enough CPU and a big enough RAM to actually hold the active processes. So this is the very basic idea of multi-programming. So you need to have multiple programs running while waiting for some tasks to be done by the I/O devices. And then in this scenario, again, you have a three program now. So basically, you have A, B, C. And then while waiting, and then you also have A, B, and C. So if you have four program, you have four programming or four program that can execute in the memory. Again, the requirement is that you must have a big enough RAM to actually accommodate many active processes, and then you must have a fast enough CPU to actually do the processing for each and every task that is coming. So this idea of multiprogramming is the central theme of modern operating systems nowadays. So the idea that came from multi-programming batch system is that to have several jobs that is ready to run, it must be kept in the memory or RAM, which then requires a proper memory management algorithm. And then of course, these come with the idea that requires a scheduling algorithm, which we will look later on in a scheduling chapter. So these are some of the building blocks of what we have today in modern operating system. So although multiple batch programming was efficient, it is still desirable to have a system where the user can interact directly with the computer. So remember, in the batch system, okay, we have a system that is not the user doesn't actually interact directly with the computer. Remember, you actually giving the task to the operator give the task to the monitor assigns the CPU. And although you have the multiple batch where you can run multiple programs at the same time, which actually saves the waiting time, but people still want to have the requirement to actually interact directly with the machine. So then they came up with the idea of having a time sharing system. So in the 60s, the idea of having a dedicated personal computer is basically almost impossible. So they developed the concept of time sharing. So what is actually time sharing? So the idea of a time sharing system, you have one processor and then you have multiple terminals. So the terminal actually consists of the monitor and the keyboard and mouse perhaps. Alright, so you can have one central processor here, okay, and then you have multiple machines or terminal that the user can come in and type in whatever they want on the machine. So usually, remember, in the old days, computers are using for calculation. So it's enough that the user comes in at the terminal, okay, and then submit a code or a program, and then the program is being run by one central CPU. So here you have multiple users, you have one central CPU. So the processor time is being shared among multiple users. So remember, this processor is being switched among the users. Okay, so because the concept of CPU time, okay, you need to understand is that the CPU switches between one user after another. And of course, because CPU actually execute very fast, so the intermittent between those swap of machine is not very noticeable, because you need to remember that the job that's being sent are usually calculation job. Okay, so when one job is being sent, the other one is perhaps still writing, and then this one is perhaps waiting for the program to compile. This one perhaps is waiting for the program to actually finish calculation. Okay, and because the concept is very new, okay, so the waiting time during that time is very much acceptable. Of course, by your standard nowadays, perhaps you cannot actually be patient enough to wait for the CPU to actually done your task. Okay, but the idea here is that the user can interact directly with the computer instead of handing over the job to the operator. So now the user can interact directly and send jobs directly to the computer, where you have the time sharing system. So the definition of time sharing is that you actually share the CPU time. So the CPU is divided among equally with the users. So let's say this one 5 microsecond, this one 5 microsecond, this one 5, this one also 5, and then swap again to the first users. Okay, so in short burst of time, okay, this CPU will swap between one terminal into another. So from the concept of time sharing comes also the definition of time slicing, because you have the CPU that needs to be divided into multiple users. Okay, so the CPU needs to always be interrupted among multiple users. By interrupting mean is that, okay, each user will have their own timer. So let's say you have currently 5 users, right? And then you have one CPU. And then let's say in terms of to just simply send the idea to you, okay, let's say in 60 seconds, you have 5 users. So the 60 second here is being divided by the 6 users there. Okay, so 60, for example, divided by 5, you have perhaps 12 seconds per user. Okay, so just imagine that perhaps this is 12 microseconds. Okay, so for each of the time allocated to each of the user, so for each interrupt, the OS will actually interrupt the time. So let's say after 12 microsecond, okay, now the control is given to the second user. So after that, 12 microsecond is up, it is given to the next user. So this process continues, okay, after every cycle. So each time the job is being sent, okay, then a certain timer will activate. So after 12 microsecond, okay, now it's time for the second user to actually do the processing. And then this one is being paused. And also the other one is also being paused. And then second user, after 12 microsecond is over, it is swapped to the other users. Okay, so this burst of interrupts continues until the user task is done. Okay, again, okay, this is a very old system and is very acceptable back then according to the that standard in the end. Okay, so the OS there will always monitor the execution of each of the program in the time sharing system here. So it is swapped between the users. This one, after that this one, after that this one, after that this one, until the job is finished. So this is the concept of time slicing in a time sharing system. Okay, from the time sharing system also comes certain consideration and afterthoughts that contribute to what we have today in the modern operating system. So of course, during the execution at that time, the time sharing system is considered primitive, but it was very effective because it gives the option to the user to actually interact directly to the computer. But it raised some new problem for the operating system. Because you have multiple jobs in the memory, then there must be a requirement to protect each of those memory usage from interfering with one another. Meaning, there must be a certain protection mechanism to protect the use of the shared memory among multiple users. So you have now multiple users on the system. So how to ensure that the process that is running by user 1 will not interrupt the process that is running from user 2. Okay, so the file system must be protected so that only authorized users have access to a particular file that they are using. And of course, remember you have established before the kernel mode where you have the user mode and the kernel mode. So this can also be used to actually protect the user file system. So the protection is the concern that is raised from the time sharing system that is nowadays being implemented in modern operating system. So you need to remember nowadays we have multiple processors instead of multiple users sharing the same CPU. But the concept of having multiple processors running on the same machine by one CPU came from the time sharing system. Alright, so before we continue to the next part, okay, please remember on the previous part we look at the evolution of the operating system, where we begin from the serial processing system and then the batch system, the simple batch, and then we have the time sharing system. So from each and every one of those evolution in the computer system, okay, remember what came out from each and every one of those evolution. Okay, those are the points that you need to remember. So before we proceed, okay, please take a 5-minute break and then you can continue to part 3 for achievement and advancement in modern operating system. So when we talk about operating system, we need to see the operating system as a big connecting system that works together. So in terms of advancement, the development of operating system must always include these 5 categories, which is the processors, memory management, the information protection and security, the scheduling and resource management, and lastly, the treatment of the operating system as a big system structure that needs to work together. So before we go further, we need to look at the definition of the process itself. So there are many definitions of a process. The simplest one is that a process is actually a program in execution, meaning any program that is executed is a process. The keyword here is the execution. So a program that is not executed is not a process. So basically, for example, you install an application on your phone, an app. Okay, so when you click or when you touch the app icon, and then the application runs, so that is a process on your phone. Another definition, you can see the process as an instance of a running program. So remember, a program is wrote, and then when you wrote it, it needs to actually run to serve its purpose. So that is also one definition. And the third definition is the entity that can be assigned to and executed on a processor. Means that when a program is running, the processor needs to actually process it. And then the last definition is basically a unit of activity, okay, characterized by you have a thread of execution, you have the current state of the process, and also you need to actually assign certain resources to the process. Okay, so those small things that connected to the process, we will actually explore it later on in other chapter. But simply put, you need to actually remember a process is a running program and a program in execution. And as do all other things and innovation, so the development idea spawns from the problems that people encountered. So remember back in the previous part where we have the evolution of the system in the computer. So we have from serial processing, the batch system, you have the simple batch up until the time sharing system. So from all those evolution, people actually came up or stumbled upon certain problems. So these problems created perhaps an opportunity for idea to grow and for innovation to come in. So in terms of OS and also the processors, it is the same thing. So for example, the development of the process comes in terms of three categories. So you need to look at the development in terms of there's multiprogramming batch operation. Previously, remember from the batch system, where the process is switched among various programs residing in the main memory. Because you have multiple program now, and this program needs to execute. So from there came some sort of innovation and ways to how to actually switch and change program that resides in the memory, because you have multiple program needs to run, because nowadays modern operating system we have many application running. And then from the time sharing system, how do the OS needs to be responsive to individual user, but at the same time have many users coming in simultaneously. So from time sharing comes the concept of where you have multiple processes that needs to actually be processed and also be given the resources on the computer. And the third is the real-time transaction system, where of course nowadays people are interacting directly with the machine compared to the old days where people actually do one processes at a time. Nowadays, people are actually using the transaction in real time. So for example, you are actually wanting to play your games currently, and then you also want to actually do monetary transaction perhaps on the banking system, and also at the same time you want to watch movies or listen to music, for example. So these are real-time interaction that people actually want fast, okay, and on-the-spot response by the operating system. So from those requirements comes the development of what we have today on modern operating system. So process coordination includes problem that needs to be solved in order to make sure that the OS operates very well. So among others, the process that need to be considered or the process concern that need to be considered when designing the system software is, first of all, the problem of improper coordination and synchronization. Simply put that, okay, let's say you have multiple process, okay, and this process needs to be synchronized in terms of, okay, let's say what program comes in and then what programs comes out and what program must need to actually wait for execution. So this requires proper synchronization between the process and the resources. Okay, so for example, I'm giving you a task, okay, an assignment. So how to ensure that there is a proper timeline for you to actually submit the assignment, and then after that for me to actually grade your assignment. So that is just one simple implementation of synchronization, meaning I give the task, you do the task, and then you pass back the task to me, and I actually graded your task. So this is also one way to look at synchronization. So imagine you have multiple processes coming in. Each of those processes requires the resources on the computer, and then after the task is finished, so we need to actually slot in another task and actually bring that task out from the memory. So this requires a very tight synchronization, okay, because as a user, you know, you can run multiple processes. So how to ensure that the system does not crash from improper synchronization? So that is the first problem. And then secondly is the problem of failed mutual exclusion. Mutual exclusion, we will actually go into that further in other special topic just for it. But for now, just imagine, okay, one program is actually holding one resources. For example, it's holding an input-output devices, and another program wants it. So by having a proper mutual exclusion, it means that each program understands that the time is over for a resource, and then it will need to give back the resource to the system so that the resource can be given to another program. So when we have failed mutual exclusion, that doesn't happen because one program simply hold on to the resource too much, while the other one is keep hanging and waiting for the resource to be released. So you have a failed mutual exclusion. And then the third one is a non-determinate program operation. It means that if an operating system is designed poorly, okay, the OS cannot actually determine which program will end, which program actually starts. So a fail in that particular area of operating system design will ensure that the OS will not work properly, and there will be constant, perhaps, process lagging or the hanging of a process because the OS failed to actually schedule a job so that there is proper order in terms of process execution. And then, of course, lastly is a problem of deadlock. Okay, deadlock can come from the improper synchronization, also failed mutual exclusion, and the non-determinate program operation. Deadlock means that there will be a, a condition where there is two or more program that ends up waiting, okay, for another program. So for example, one program is holding the resource that is needed by program B, while program B have a resource that needs to be released by program A. Okay, and each process cannot proceed because they are waiting for each other to release the resource that each and every one of it once. Okay, so if there is no proper timing, there is no proper synchronization, there is no proper mutual exclusion, so deadlock might happen. So these are the things that usually the developer of the system software of an operating system needs to consider when they are designing and implementing, okay, what to have in the operating system. But the key concern is this four category when we talk about coordinating process. So you need to have proper synchronization. You need to have a better mutual exclusion understanding between processes. We need to have a determination or a determinate number of when process can operate so that the OS know, okay, how long does the process need to actually execute, okay, and then what are the limit of the process execution, and this is to ensure that process doesn't end up in deadlock. So in order to successfully manage a process, the OS must have a set of information to properly manage it. So when we actually designing a process, there are three important components of a process. So first of all, of course, a process needs to have its directive in terms of what is the code, what is the executable program that the process is written from. Okay, for example, you have an application for calculating, let's say, a salary. Okay, so the code actually requires certain variable and data. So that comes in terms of the second component. What data that the process needs to actually process on. So what are the variables? Let's say you have your monthly salary, for example. You have perhaps tax deduction, then you have the summation or deduction from that amount. So that is the data that it needs to process. And then third one is the execution context. It means that process needs to be able to tell the OS, okay, currently what is the status of my execution. Okay, if it's running, okay, then it will tell, or there certain indicator to the OS, okay, that currently what is the process doing. Okay, so we will talk about this process state later on in a specific chapter, but for now you need to remember for process there is these three important components. So there is the program, the code, the directive, and then the data, what is it working on, and then thirdly is the execution context. What is the progress of the process so that it can be properly planned and synchronized with other process, because remember, process are sharing resources. So if the OS doesn't have this information, it cannot properly plan ahead or perhaps give proper timing to the process in order for it to execute successfully on the system. The second important development in modern operating system is of course about the memory management. So modern operating system has 5 principal storage management responsibility. These include process isolation, the automatic allocation and management of memory, and then the support of modular programming, the protection and access control, and also in terms of long-term storage. So first of all, we talk about the process isolation. Most importantly, you must remember that you have many processes that requires the use of resources. So in terms of managing this, the process must be managed as a separate entity and must be isolated from one another. Because remember, one of the most dangerous threat is that one process can actually interfere with the execution of the other process execution. Remember when we have viruses? So that is one example of a process actually interfering with the other process execution. So a proper operating system must have the ability to isolate this process, meaning when a process enters, it cannot interfere with what other processes is doing. And then secondly is the automatic allocation and management of the process. It means that once a process enters the system, it must immediately have automatic allocation and be managed, meaning that, okay, remember that those three components of a process. So basically, by actually looking at the process, for example, OS immediately know what a process needs, how much time is needed, and then how to actually allocate these resources based on the requirement of the process. So that is the second responsibility. Third is the support of modular programming. So this third requirement or responsibility is, let's say you are a programmer. So as the one that is written or writing the code, okay, so you must be given option to how you actually want to write your program. Of course, as the one that you have previously perhaps learned about programming, you know that program has classes, program has procedure, program has certain module that you actually write to actually do certain things on your computer. So by having that option, so programmers can write different modules for a program and actually design how a program should react when it runs. So that is the third requirement. And then the fourth is the protection and access control. So there must be a proper mechanism to protect processes that are running, and also there must be a certain way where a process can actually be restricted from having too many access to it. So previously you have the user mode and the kernel mode. That is one example. And also there must be a certain restriction of access to ensure that the OS have the priority to actually manage this process and also control that no actual process can have too much freedom to actually do what it wants. And then of course, lastly, in terms of long-term storage, of course, when all is said and done, when a program finishes execution, every program wants to actually save certain data. And as a user, for example, you want to ensure that you can actually return back to your work. Okay, so that is the last requirement, to have a long-term storage so that works can resume, and also in terms of residing in the memory, how long is it? Okay, so these are the 5 principal storage management responsibility of the OS. Basically, it talks about how process needs to be properly isolated, properly managed, properly written, properly protected, and the ability to have a storage mechanism. So these are in terms of the memory management advancement. The third advancement in modern operating system is actually a separate field on itself. But simply put, a modern operating system must be able to actually protect whatever it has on its system. So these include, first of all, concerns of availability, confidentiality, data integrity, and also authenticity. So in terms of availability, it means that when the system is secure, the OS must ensure that whatever is being requested by the user or whatever resource that it has on the computer should be available when it is requested. Of course, this must be supported by the second pillar, which is confidentiality. Confidentiality means that only authorized processors or perhaps authorized users are given the privilege of availability. It means that, okay, when you log in into the system, you introduce yourself to the system by having your username and password, or perhaps you have certain gesture that you input to the computer. So once the computer recognizes it, so you can have availability to that data. And by having proper confidentiality mechanism, you can also have proper data integrity. It means that, okay, for example, you are introducing yourself to the system so that that system can actually recognize that currently which user is currently logged in into the system. And then whatever you written, let's say you have written a document, for example, and you are requesting the document or you are producing a document, so other users can ensure that you have data integrity. It means that the data that you produce can be trusted, and of course it came from you because you properly given your proper credential. The system recognize it, and by having that, your data can be trusted. This is also true for processes. So when the process properly introduce itself to the software or the operating system, so the process can trust one another. And then lastly, by that, you will have proper authenticity of information. Because you properly authenticate it, you have proper data integrity, you have proper confidentiality, thus you can also have authentication of information. So these are the third advancement in modern operating system in terms of information protection and security. Now the fourth advancement is of course the capability of the OS to properly schedule and manage resources. So this is actually the key or the main responsibility of the OS in managing resources. Remember the three categories of resources. We have memory, we have I/O, and also we have the processor. So these resources must be properly distributed and given to the processors when requested. So in terms of resource allocation policies means that how does the OS needs to actually respond to the process request for getting the resource. So first of all, there are three categories. So you can see here, there are in terms of fairness, differential responsiveness, and also efficiency. Fairness means that each resource must be given equal opportunity when it enters into the system to actually request for resource. Secondly, they have differential responsiveness. So although there must be fairness, there must also be a certain different responsive depending on the category of process. So for example, remember you have kernel processes, you have also user processes. So when something go wrong, okay, in order to make sure that your computer operates smoothly and continue to operate, there must be the ability for the OS to actually differentiate between important or higher priority process compared to the lower priority program. So for example, you are running a game on your computer, and then on the other hand, they need to actually run system processes to manage these resources. So let's say your RAM are not enough, the memory is not enough. So the OS needs to decide which process needs to actually terminate. So that is an example of differential responsiveness given certain priority to critical processes. And then the third one is having an efficient way to actually execute. So this policy actually consider, okay, it needs to run as many program as it can on the machine, and given resources to as many process that is requesting it. And then at the same time, properly make sure that the process can run without actually uh, disturbing or perhaps harming the system itself. So running as much process as possible, given away as much resource and manage as many resource as possible, and to ensure that proper performance is running on the computer that it is managing. So these are the key policy in terms of resource and scheduling management. And the fifth advancement in modern operating system is to treat the operating system as a big system structure. Because remember, there are many things that are needed to be done by the OS. So basically, you need to actually, when designing your operating system, perhaps you can have a big team to actually cater for all the things related to the operating system. Because you need to actually manage the hardware, manage the application, manage the resources, and how to actually interact with one of those, each and every one of those components in order to make sure that your OS works properly to manage the process and the resources on the machine. So when we treat your OS as a separate entity that actually integrate or interact with one another, then you can properly design it so that, let's say, there's certain patch that need to be done. Okay, so that patch can actually cater for that particular module only. So by seeing the OS as a big system structure, it also eases or perhaps make sure that the development of modern operating system is much more manageable and much more well organized. So by that, this ends our first chapter on the introduction of operating system. So before we end our session, make sure you review what we have learned today in our session. So first of all, the basic functionality of operating system, okay, where we have the OS as the middleman or the mediator between the user, the application, and the hardware. Secondly is the history of the operating system, where we see step-by-step or one-by-one advancement in the operating system or the basic idea that contributes to what we have today in modern operating system, where we begin from the serial processing system up until the batch system, the simple batch, and also the time sharing system. So from all those evolution in the operating system, it contributes certain bits and pieces of what we have today in the OS advancement, where we need to know that the OS manages process. What is a process? And then of course in terms of security, in terms of scheduling and management, in terms of the managing of resources, and also to understand that the OS is a big system that interact in order to manage the process and the resources on your computer. Okay, so by that, I end today's chapter and I hope you benefit from whatever I have shared with you today. So before we end the day, now I am delivering you your first group assignment. Remember previously in our group, I have asked you to actually form a group of 2 to 3 people. So this is the task. So you need to actually choose one version of an operating system. So for example, you have Windows, Mac, Linux, or even iOS and also Android. So choose one and choose the latest one version that you have. Okay, for example, Windows, you have Windows 10 now. And also for perhaps Android and iOS, you have the most current version of the Android or iOS on your phone. And then write a brief history for each of the OS that you have chosen. So what is the history? Perhaps what are the previous version or the prominent version that you have on the operating system. Don't touch too much, just perhaps what features that it has, okay, from the very beginning of the conception up until what it has today. Year it was conceived, and then the current version, okay, the platform that it was intended for, is it for personal computer or is it for the phone? And then 3 of its latest version. Okay, perhaps you can choose those 3 is the most prominent one. And then have a read or have some fact-finding mission on how to each process, how does it do application or process management. Secondly, how does it do memory management? How does it do device management? Okay, so do this in your group, discuss properly. If you have any question whatsoever, feel free to ask and discuss with me. So you need to submit the report to me in 2 weeks time, let's say before the second Friday after today. Alright, and then perhaps prepare, apart from your report, the PowerPoint that you need to actually present, okay, during the presentation session. Okay, so by that I end today's session, and any question feel free to ask in our Teams or chat. So thank you very much for joining, and I hope it has been a very beneficial session to all of you. Thank you very much for joining, and I see you again in another session.